In this video, we are going to continue practicing conversion problems. Now we are going to be doing book problems. We're going to focus on the problems on page 75, problem 2.60. It states, use metric conversion factors to solve each of the following problems. We're going to work specifically on letter A and B. On letter A, it states the daily value of phosphorus is 800 milligrams. How many grams of phosphorus are recommended? So for problem 2.60A, the given amount is 800 milligrams. The needed amount, which is what we're trying to calculate, is going to be in units of grams, which the abbreviation for grams is the small letter G. Because this is a metric conversion, we can utilize the techniques that we learned in the previous video. I am personally going to illustrate both the number line method and dimensional analysis. When we look at the relationship between milligrams and grams, using the number line method, we can find that 1 gram equals 1,000 milligrams. Now that I have my equality, I can tell that 800 milligrams, when I set up the problem, I'm going to put in the bottom the part of my equality that matches milligrams, which is going to be 1,000 milligrams. On the numerator, or on the top of my fraction, I'm going to put what 1,000 milligrams equals to according to my equality, which is going to be 1 gram. When I take these two numbers and I divide them, I find that my calculator display shows 0.8. Because the given amount has one sig fig, my result must be expressed as one significant figure. So according to the problem and dimensional analysis, my final answer is 0.8. If I use the number line method, what is given, I'm going to highlight, which is milli, is right here. 800 milligrams. And I'm converting it to my basic unit of grams, which specifically, let me just redraw this arrow, is going to be at this point where I have my basic unit. So that means that in the digit 800, I'm going to move the decimal place 1 time, 2 times, 3 times to my needed unit. In the value of 800, we have an implied decimal place after the last 0, which is here. And when we move it 1 time, 2 times, 3 times, then the decimal place will be now living in this area, meaning before the 8. So you can see that we get the same number, 0.8. Let's proceed now to do letter B. In letter B, it states, a glass of orange juice contains 3.2 deciliters of juice. How many milliliters of orange juice are in the glass? So the units that are given is 3.2 deciliters. We need to convert that to milliliters. Utilizing the number line for dimensional, for determining the equality between deci and milli, we can find that 1 deciliter equals 100 milliliters. Utilizing dimensional analysis, 3.2 deciliters. That means that every deciliter, because we're trying to cancel the units, let me just write it in the top problem too. The deciliters cancel. On top of my fraction, I'm going to put what deciliters equals to, which is 100 milliliters. So when I take 3.2 and I multiply it by 100, I find that this equals 320 milliliters. Similarly, if I use the number line method, let me erase the work that I did for letter A, and I can now do the work for letter B. The given unit is deci, so that means that my starting point is at this location. I need to end in milli. So if I start with the value 3.2, I have a decimal place that it is written. In order to go from deci to milli, I have to move that decimal place 1 time, 2 times, from left to right, which means that I move it 1 time, 2 times from left to right. There is a pocket that is open. I populate it with a 0 because remember that the relationship between the prefixes in a metric system is going to be by some power of 10. So you can observe that this turns into the value 320, which is the same result that we obtained by dimensional analysis. Make sure that you practice problems C and problem D. We're now going to move on to the problems that we see on page 87. These selected problems are going to require more than one conversion factor in order to accomplish the goal. Let's go over together problem 2.99, which states, in France, grapes are 1.95 euros per kilogram. What is the cost of grapes in dollars per pound if the exchange rate is $1.14 per euro? Let's actually write down all the information that is given. The first thing that we need to consider is that specifically our grapes are costing 1.95 euros. The shorthand is EUR. So capital EUR. And when it says per kilogram, that says per over 1 kilogram. This is what is given. In addition, we need to find what is the cost in units of dollars per pound. So those are our units, dollars per pound. You can also write dollars per pound as USD per pound. The other piece of information that is given is in the problem is the exchange. How many dollars correspond to a euro? So we have an equality given. That equality is $1.14 of US dollar equals 1 euro. So taking this into consideration, let's write down the cost of these grapes per kilogram, which means that 1.95 euro is going to cost us for 1 kilogram of grapes. Using dimensional analysis, we can get to the units of US dollars per pound of grapes. The first thing that we could do is change specifically the euro to dollar. We learned before that because we need to cancel a particular unit, we're going to cancel it diagonally. So if I'm trying to convert euro to dollar in dimensional analysis, I should take this equality and put it as a fraction in which in the denominator, meaning in the bottom, I'm going to put the unit that cancels with one of the ones given. So here I can say 1 euro, and then on top what it equals to. 1.14 US dollar. So by setting up this fraction, I can cancel the cost in terms of euro, and then the units that are remaining at this time in the problem is just US dollar per kilogram of grapes. The problem is requiring us to change per pound. So if I'm trying to cancel the unit of kilogram, I need to put it diagonally to it. So in the next fraction, I can actually look at the relationship between kilogram and pounds. We can observe that in table 2.7, there is a relationship between kilograms and pounds, which states that 1 kilogram equals 2.20 pounds. Because units always cancel diagonally, the kilogram units here can cancel with the kilogram units in this numerator. So when we are solving this problem, we can state if we take 1.95, multiply it by 1.14 USD, which is our remaining unit at the top, and we take everything and divide it by the value of 2.20 in the unit of pounds, you can observe that already we have USD to pounds like the problem is asking us to do. So in our calculator, what we enter is we take 1.95, we multiply it by 1.14, then we divide it by 2.20, and we observe that we have a calculator display with many digits. The final result for this problem, it's going to depend on the significant figures that were given in the problem. So as you can see, that is 3 significant figures because we have them right here. So when we round it, our final answer is going to be $1 with 1 cent, because when we round it, that is going to be the final answer based on the calculator display. The calculator display looks like 1.01045, and there are other digits present. In order to practice, try problem 2.1000 or 2.100.